let's look at some other principles. Okay. Now, in this case, we're done with boarding school. We're now going to go to one of my favorite places downtown, Big Dipper Ice Cream. Okay. So I'm in Big Dipper Ice Cream, and what I discover is that they have three different types of cones. They really do have three different types of cones and six different flavors of ice cream. I simplified that. They have like 200 different flavors of ice cream. Okay, I'm exaggerating now. Okay, so how many combinations of ice cream cones can we make, right? So here's what I want to have. What I need is a cone, right? And then a scoop of ice cream. Okay, so how many ways can I choose the cones? Hey, they have three different types of cones, right? And then six different types of ice cream. So I can fill the second slot in six different ways because I'm choosing one of each, right? Then I have a Cartesian product combination. So the answer here is 18. Okay, I can make 18 different orders of cones. Okay, that's great. Now let's make this a little bit more complicated. Let's say that I have two scoops of ice cream that I can do. All right, so how are we going to solve this? The same way, right? We have the cone, we have a scoop, and then we have another scoop. Right? I can put three different ways here, six there, six here, and then the answer is going to be 3 times 36. 3 times 30 is 90, 18, so it's 108. Okay? All right. That's pretty awesome, right? Now this is the kind of problem that you actually have to be a little bit careful with, okay? Because, for instance, let's say that I choose a nice scoop of cherry ice cream, okay? And now on top, I really like cherry, so I want that to also be cherry ice cream, right? That's actually one of the possibilities that we have here because we said scoop 1 could be any of the 6 flavors, scoop 2 could be any of the 6 flavors, so they could actually be the same flavor. Should that be allowed, or do we actually mean for them to be different, right? Well, if we mean for them to be different, then this number should not be 6, right? This number should be 5. So 5 if we want to be different flavors. Okay? Okay, now what else could happen? Well, look, this is not necessarily correct because let's think of this scenario, right? I have an ice cream and I select cherry again, okay? And let's say that I'm feeling absolutely insane, so my second scoop is chocolate, okay? Chocolate ice cream, worst invention in the world. You can disagree. All right, so now I have chocolate on top of cherry. I could also have picked chocolate and then cherry on top. Is that the same choice or is that a different choice, right? Well, it's up to us to choose, right? And that's the problem. This is not very well specified. This is a little vague, right? That's what I was talking about. When it's vague, it's actually harder to count. But here we need to decide whether these are the same or these are different, right? If they're the same, okay, then, well, we're done, okay? If they're different, right, then I'm going to, well, let me rephrase that. If I consider these two things to be just the same scenario, right, this is just cherry and chocolate in whatever order, then I've actually picked too many, right? So what I'll have to do is divide this by 2, okay? Because there's 2 ways to put cherry and chocolate. The cherry can go on top or on the bottom. So 2 different ways. And they're both the same, so I'll have to divide by that, okay? Now, again, I have to be super careful because if cherry and cherry is actually okay, right, then I can't divide by that because I can't tell them apart, right? Cherry and cherry or cherry and cherry. So actually, they were already kind of only one choice. So it gets even more complicated, right? What I would have to do is take the 6 and 5, which are the different choices. That one I have to divide by 2. And then now I only have 6 choices because I choose the bottom one and the top scoop is already chosen for me because it's got to be identical. So I would take the 6 and 5 divided by 2 plus, because these are disjoint, plus the 6, right? So I would end up with something that looks like this. 3 times and then 6 times 5 divided by 2 plus 6 times 1. And that would be the answer for 2 scoops, that have to either be different or the same flavor. We're not going to specify, but if they're different flavors, then it doesn't matter which one's on top. Okay, so that's how I would count that. I notice there I'm making explicit use of the sum principle. Right? I told you this got tricky. It's simple principles, but you know, it's not always obvious what the correct answer is. Okay, so let's look at a different example. Okay. Now what I'm going to do is I noticed that not only do they sell cones, waffle cone being my favorite, they also sell really nice, you know, quarts. Okay, and I really like ice cream, so I want to take 3 quarts home. So how can I do this? Again, 1, 2, 3, right? Each possible quart. So here, how many choices can I have? I can choose 6. Here, how many choices can I have? I'm going to choose 6, right? And here I can choose 6. So I could say that the answer is 6 cubed. Okay, that's a pretty decent choice. Okay. On the other hand, maybe, right? What I actually want to do is not really choose 6 of them. Perhaps what I was interested in is I want to take 3 different kinds of quarts home. Okay, so if I'm going to be doing different ones, then the first one I have 6 ways of doing it. The second one I only have 5 ways of doing it, and the last one I only have 4 ways of doing it. Okay, so that's the answer, isn't it? Well, not exactly, because I could have chosen cherry. Okay, I could have chosen vanilla, and I could have chosen strawberry. Right? That's what I want to take home. But how can I tell the difference between that and cherry, strawberry, and vanilla? Right? When I get home, I still have 3 quarts, and they're the same quarts, right? So in some senses, it doesn't matter how I made the order, in what order I made the order for these 3 things. So that's actually too many. I have to divide by the number of ways that I could arrange that ordering. Okay. Okay. So how many different ways can I arrange that? Well, what I could argue is that, and I'm using the same technique that I used up to this point. How many ways can I pick the first flavor? And the answer is 3 ways, right? Because I got 3 flavors I'm going to pick. And the first one, which one, which one do I ask for? Well, I could choose one of those 3. All right, that one's taken care of. How many ways can I choose this second one? 2 ways. Okay, awesome. How many ways can I choose the last one? Well, only 1 way, because there's only 1 flavor left, so that one, right? So that would be the answer, okay? Interesting, right? So it actually makes a difference as to whether I want to count repetitions, right? Same flavor multiple times. Does that count or not? And also, how many ways can I count? Should I count orderings, right? Do I care about the orderings or not? Both of those need to be considered. Okay, I want to pursue this a little bit more. Okay, so bear with me, but you know there seem to be a few possibilities. Okay, so here's what I'm worried about right now. Suppose that I want to have allow repetitions, because I'm going to argue that if I choose 2 vanillas and 1 strawberry, you know, that's okay, right? You know, that's one of the choices I can make. Okay, so I want to allow repetitions, but on the other hand, I don't care about the ordering. Okay, so how can I do this? So I have 3 things that I'm choosing, right? I was saying that I'm going to allow repetitions. So it's somewhat tempting to just say 6, 6, and 6. Okay, and now let's worry about the ordering. Except that's not really true. And here's what I'm worried about. I'm worried about doing cherry, vanilla, and then cherry. Okay, so now think about all the ways to order those. Oh dear, you know, I could have some kind of a mess, right? Because I can't tell the 2 cherries apart. So I could order a cherry, vanilla, cherry, you know, and so on. So it's actually easier to kind of rethink this, okay? And here's what I'm going to do. Okay, I'm going to say that I choose 3 different ones. 3 different flavors. Okay, so now I know how to add these. This is 6 5, and 4 because they have to be different flavors, right? And I don't care about the ordering, so I'm going to divide this by 3 times 2 and 1. Okay, so that's my answer, right? Whatever that turns out to add up to. Okay, let me write this a little better. 3, 2, and 1. Okay, so that's for 3 different choices. Now let's think about 2 different ones. Okay, so this is what I'll do. The first one I'm going to choose 6, right? Now, the second one, I said that I was going to choose only 2 different flavors. So what I'm going to say is that that's the same flavor as the one that I just picked. Okay? And as far as the last, well, I can choose it in 5 different ways because the only thing that's not correct is to choose the one that I've already picked. Okay? Now, I want to allow kind of reorderings at will, right? So what kind of reorderings can I count here, right? Well, let's say that I pick vanilla, and cherry, right? You know, guys, that's actually there's no ordering happening here because I know that I picked vanilla is 2, cherry is 1, right? So I can't actually tell these things separately. Okay, notice that it's always going to be the vanilla, right? And then I have to pick vanilla again, and then the cherry, right? So that's actually different than cherry, vanilla. Okay, so actually there's nothing to divide by. Okay, there's the ordering here. They're all different. Okay, so I'm good. All right. Okay, now how about if I pick 1 different flavor? Okay, well, first guy 6. The second one is the same, right? So there's only one way of doing it. The third one, there's the same. So there's only one way of doing it. Again, what am I going to divide by? Nothing, right? Because there are no kind of reorderings that matter. Okay, it's not like cherry vanilla. Oh, and vanilla cherry. No, it's just cherry, right? There's only one way to do that. So again, here I'm dividing by 1. Here I'm dividing by 1. Okay, and then what do I have to do? I figured out all the different ways that I can pick 3 different flavors, all the different ways that I can pick 2 different flavors, and all the different ways that I can pick 1 different flavor. So I add all these, right? And that gives me the answer. Okay, so again, I used the sum principle, I used the product principle, and I took very careful to avoid over counting because of repetitions, and I'm sorry, not repetitions, but reorderings, right? And all of those kind of come together in just this one problem. All I'm doing is choosing ice cream. It's a lot more complicated than it looks. Just a handful of principles, but many different ways to apply them.